Hello dear students, welcome again to this science class for class 8. Today also we will be continuing with what we left off in the previous class, that is chapter 11 of our textbook, Force and Pressure. Now, in the previous class, we described force as a push and pull of an object, and then we also described force as a force is applied to change, stop, or move an object. So we have concluded in the previous class that force may change the motion of an object, or it can make an object start to move. It can change the speed of an object, or force may change the direction of motion of an object, and force may change the shape of an object, or force may change all of this, affect all of this, or some of these effects. So that was what we concluded in the previous class. And then we also learned about the type of force. We learned about contact force, that is, we learned from the question that I raised up, whether you can leave the book without touching the book. From that question, we were able to find out that when we have to touch the book to leave that book, right? So we came to the conclusion that we need to be in contact with the object to apply force. And then when we lift that book, we are using our muscles to lift that book. So we describe that type of force as a muscular force. And then we also learned about another type of force called friction, right? The force that is responsible for making a rolling ball stop, right? It is that force that makes a vehicle comes to stop when the brakes is applied, right? So we learned that this friction and the muscular force are the two types of contact force. Now, in this session, I'd like to introduce you to another type of force which we can experience without the two bodies interacting, without the two bodies touching each other. And to understand that force, let me introduce you to a material called a magnet. I hope you know what a magnet is, right? So if we have a magnet, then we know usually all magnets have two poles, right? Suppose this chalk is a magnet, then we have a north pole and south pole on a magnet, right? And if we bring two magnets together, then the south and north pole will start to attract, right? It will start to attract because they are, the north and south, since they are from the two different poles, they will attract each other and they'll come together. Even if we don't push them or pull them, that two magnets will come together, and there is a force which makes that magnet come together, right? So that force is that force is a magnetic force. And suppose if you bring the same pole together, like north and north pole, then you find that as you bring it closer and closer, the magnet will start to push each other away, right? Because the same pole of a magnet will repel each other. So in this case, the magnets are not touching each other. There is no contact between the magnets. So that is why this kind of force is called a non-contact force, and this force produced by a magnet is called a magnetic force. Now, if we think about the type of force that we can study without, I mean, the type of force that doesn't require contact, then we come across another type of non-contact force, which is very much around us. If you look in your textbook in activity 11.7, you can do a simple activity. Okay, you can do a very simple activity. Say you have you have a straw, right? That straw which you use to drink your cold drinks, right? So if you take a straw or two straws, or you take one and cut into two equal parts. Now, one of the straw you tie with a thread and hang it on a, say, you suspend it on the table, in the table, edge of the table. And then for the other straw, you rub one end, you rub the end with a paper. Okay, you rub it with a paper thoroughly, and then you bring that straw near to the suspended straw. Now, if you bring that straw near, as you come near to the suspended straw, you will find that the suspended straw will start to come towards the straw which you have rubbed with paper. It feels like it feels like there is some kind of magnetic attraction, right? Now, again, you can flip the straw, and then on the other side you rub with a plastic. Okay, you rub with a plastic. Now bring the side to the straw, near to the straw. Make sure that they don't touch. Okay. So as you bring it near, you'll find that as you bring near, the straw will move away. So it means they repel each other, right? Now the straw is not a magnetic material. Okay, there is no magnetic material. The paper is not magnetic, nor is the plastic. So why did that happen? Why does that happen? It is because when you rub the straw with a paper, then the straw acquires a kind of force. It acquires a kind of force when you rub it with the straw, with the paper or plastic. So this force which the straw has acquired is due to an electrical charge called electrostatic charge. It means it is just that when you are rubbing the straw with the paper, the straw acquires some electrostatic charge, and because of that, the straws have that character like that magnet. And this force, which we experience through this electrical electrostatic charge is called electrostatic force. Since this is also a force which doesn't require contact, this is also a non-contact force. Now, is there any other force which we can observe? And then, yes, there is still other force where non-contact of the bodies. I mean, there is no contact between the bodies. Now that force which I'm saying is responsible for, say, when you throw a stone up, it is responsible for the stone to fall down. That force is responsible for the leaf of trees to fall to the ground. It is responsible for the apple. You have heard about the story of a scientist who watched the apple fall on his head, right? And he discovered a force. So this force that I'm talking about is called the gravitational force. Okay, gravitational force. And this gravitational force is the reason why when you flip a coin, the coin will fall down, right? And now, as I've said before, the scientist who watched the apple fall down to the ground, he started questioning, right? He started questioning why the ball fall down to the ground. Why didn't it fall? It fly away? Why didn't it go up? So with that questioning, he was able to find more about this gravitational force. I mean, yes, and those you'll be learning more about gravitational force in later classes. Now, you may be surprised to know that this gravitational force is large. I mean, it's so strong. Okay, it is the reason why we have the moon revolving around the Earth. Or if you live near a big water body like the sea or ocean, you'll find that during the full moon, you'll find that the water rises, called the tide. That is because the gravitational pull of the moon is it's pulling the water up, so causing those high tides and low tides. Or for that matter, if we look around us, gravitation doesn't not only that phenomenon is not only on Earth; it is around the whole universe. The Earth is revolving around the sun. At the same time, even the sun is revolving around the core of the Milky Way. And if you look at if we study the universe, then we find that the Milky Way is moving towards the center of the universe. That's what those astronomers say. And then there is a gravitational pull which is so strong that even light cannot escape. So all this, if we try to learn, if you try to think about it, then you'll find that a big area or a big subjects open up for us to study. And this study, you will learn more and more as you progress in science. And okay, now in class 7, you have read about the formation of cyclones and like storms and cyclones, right? And how cyclones are formed. You read about the formation of cyclone due to difference in air pressure, right? When the hot air hot air rises up, cold air flows in, right? To fill up that, it causes that air pressure forming the cyclone. That was what we learned in class 7. Now, what is this pressure? What is this pressure that we are talking about? And what is this pressure that has does it have a relationship between force and, is there any relationship between force and pressure? Now, let's try to find out. Say you take a pin, okay, you take a pin or a nail, okay. You hammer the nail on a wood, okay, through its head, okay. Let's see how if that nail can enter the wood on its head, right? You find that it is difficult, okay. But when you try to hammer the nail in on its pointed end, you'll find that it's much easier, right? Or when you try to punch a hole with a pin, okay, on a paper, if you do it on the head side, it's difficult, right? But on the pointed side, it's much easier. Why is this why is it so? Now the reason is when you are pressing the nail on the head, okay, the difference is that the force is spread out. Force is spread out as you are trying to push, okay. But when you try to push through the pointed end, the force has been, they are acting in a very small area, okay, in the area of the tip of the pin or your nail. Therefore, we can define pressure as the force acting on a unit area. Okay, we can define force as pressure as force acting on a unit area, and we can write that expression as pressure equal to force by area. Now, when we look at this expression, area is in the denominator, right? Area is the denominator. And so, if area is less, naturally, pressure will increase, right? For that, let us do a simple exercise. Okay, a simple example. Say, suppose for this pressure, we are applying a force of say 100. Okay, in an area of 2 centimeters. Let's say 2. Then, what is the pressure? The pressure we are getting is 50, right? Now, when I say if the area is less, then pressure is more, right? So what I mean is that suppose instead of 2, okay, instead of 2, let's say the area is just 1. Okay, area is smaller now. So if it's 1, then we are coming up with 100, right? So that means pressure has increased. When the area is decreasing, pressure is increasing. So here, I'd like you to recall why we are able to cut objects with a knife. Okay, it's because of this thing. Okay, we are able to cut with a knife because the area at the tip of on the edge of the knives are less. If your knife is blunt, that means the edge has more area. It has more area. So when you apply pressure to cut, then since it has more area, you need more and more pressure. Whereas if your knife is very sharp, that means the edge has a very small area. That's why you need less force. Okay. So you are able to cut very easily. Okay. So likewise, even in the case of that pin and your nails also, that's the same case. This area is small, so that's why you are able to cut or pierce that with a pin and a nail. Now, let's think about the pressure exerted by other, like say pressure exerted by the air or liquid or gas. Okay, pressures exerted by liquid or gas. Now, since let's do an activity here. Since there are some students who are listening to this through the radio also, I will not show you the activity. I will describe the activity here. You try at home, and you observe. Okay, you observe. You find out your observations from there. Okay. Now, let's start with the activity. Say you take two bottles of your mineral water bottle, okay, of the same size. Let it be that 5 rupees or 10 rupees bottles, okay. You take two bottles and two balloons of the same size. Now, in one bottle, you fill the bottle with water. In one bottle, it should be more than half of the bottle, okay, more than half. And then in the other, water should be less than half. And then with the mouth of your balloon, you cover the tip of your balloon and tie it properly so that the water does not leak out. Okay, on both the bottles. Now, after you are ready with that, you flip your bottles upside down. Okay, you flip your bottles upside down. Now, compare the bulge of the balloons from the two bottles. Okay. What is your observation? You do that and see. How much? The difference in the bulge of the balloons. So that will be your activity. You can also investigate this further by doing another activity, like you take another bigger bottle. Okay, a bigger bottle with say 1 liter. We have that 1 liter soft drinks bottles, like the Coca-Cola bottles. You take that, and near the base you drilled say 2 or 3 holes. Okay, from the same distance. From the same distance from the bottom. Okay, so you drill a hole at the base from the same distance, and then fill the bottle with water. Now, what you will observe is what we will see here as you fill the bottle with water. You find that the water will start coming. A stream of water will come out through the holes that you have drilled. Okay. Now here we can see, or we can come up with 2 conclusions in this activity. One is that the liquid that we have poured into the bottle, it is not only exerting pressure down. Okay, it is not only exerting the pressure downward, but it is also exerting pressure on the wall of the bottle. So that's why the liquids are coming out. Through the holes that you have made. That is one conclusion. The other conclusion is that if you look at the stream of water coming out carefully, you'll find that all the streams, if you have made the holes in the exact distance from the bottom, then you'll find that the stream that is coming out, there are equal distance from the bottle. Okay, so this shows that at the same level, the pressure of liquids are equal, right? Or liquid exert pressure at the same depth, okay? Now, what about air then? Does air produce that kind of pressure? Now we can recall how we blow a balloon, right? Once you blow a balloon, you have to close the mouth of the balloon, otherwise air will start to escape again. Or I would say the tires of your bicycle. When you have a puncture in the tire of your bicycle, right? Where does the air escape? Okay, as soon as there is a hole in the tube of the tire, then air will start to escape through the hole that was created, right? So if we find that like the water, even air also exert pressure, right? It exerts pressure on the inner walls of that tube, right, or the balloon. Now, what about us then? What about the air around us? Now, our Earth, the air around us, the atmosphere that we are talking about, it extends up to so many. I mean, it extends many kilometers above us. Okay. The level where we can find air. So all around the Earth, that much air is there exerting pressure. Okay. So this air around the Earth that exerts pressure on that exerts its pressure is called the atmospheric pressure. Now we have already defined pressure as force per unit area. Okay, force per unit area. Now to find out for how much pressure how much the atmospheric pressure is exerting on us. To find out that, let's take the story of a German scientist. Okay, a German scientist in the 17th century. He invented a pump, a pump that can pump air out of a container. So he invented a pump, and with that pump he demonstrated the force of atmospheric air. Okay, I mean the pressure of the atmospheric pressure. Now, here he took two hollow hemispheres. Right? A hemisphere means you have a ball. You cut a ball into two parts. Okay, so that is a hemisphere. Now he took two hollow hemispheres made of steel. Okay, so that the hollow hemisphere was large enough. The diameter of the hemisphere was 51 centimeter. That is roughly a little less than 2 feet, its diameter. And then he joined the two hollow cylinder together. Okay, he joined them, and then he pumped out all the air. Okay, he pumped out all the air inside that hollow. Since they are connected, inside that hollow hemisphere, he pumped out all the air. Now the two hemispheres have formed a sort of a ball, and there is nothing inside. I mean, it's a vacuum. Okay. So now this scientist, he brought 16 horses. On one side, 8 horses. On one side, 8 horses. Okay. And he joined the two hemispheres to the horses, and he let the horse try to pull apart the two hemispheres. Yes, there was no gum, no glue, nothing when they were connected. Okay, there was no glue, nothing. Only that whatever air was there, it was pumped out. Okay. So now those 8 horses on this side, 8 horses on this side trying to pull apart that hemisphere. Okay. It didn't happen. The horses were not able to pull apart that hemisphere because the atmospheric pressure that is acting on this, okay, is so great that even the horse were not able to overcome that. Now, so you will be wondering then why aren't we crushed by this atmospheric pressure, right? If this atmospheric pressure is so great, why am I not crushed? For example, if my head is say 15 by 15 centimeter, then the atmospheric pressure acting on me will be around 220, like a force acting on the force will be around 225 kilogram, right? If my head is just around 15 by 15 centimeter, so that much force, atmospheric pressure is there, but the thing is that the pressure inside my body is equal to the atmospheric pressure that is outside. So that is why it doesn't hurt us. Okay. Now, if you go deeper underwater, for example, if you go deeper underwater, you'll find the pressure also increases. Okay, like the atmosphere, as we have said about the atmospheric pressure, if you try to go deeper underwater, then the pressure increases immensely. That's why there are some places on Earth where even human beings cannot go because of the pressure, without special equipment. Or there are even places where say your submarines cannot go because there are so much pressure that the pressure of water that even our submarines cannot reach. Okay, so as we come to this to this end of these lessons, let us quickly remind ourselves what pressure is, right? We define pressure as the force per unit area, okay, per unit area. And then we also learn that liquids exert pressure at the same depth. Liquids exert pressure on the walls, and even air exert pressure on the walls and on the okay. So now with that we have reached to the end of this chapter. I hope that if normal classes resume, if normal classes doesn't resume, maybe we may continue with this class. Hopefully, we may continue or we may not continue. Maybe if our classes resume, then it will be good. Till then, please maintain the hygienic practices that have been advised to us, right? Like wearing a mask when we go out, or washing our hands using hand sanitizers. Okay. So when you go out, when you go out and come back, you wash your hands, use the hand sanitizer. So you follow all those practices. And then above all, please stay at home. Okay, please stay at home and stay safe. Till then, it's goodbye from here.